Alright, welcome back to the SciMax channel. Today I'm going to tell you about another feature I've recently put into litdb, which is an LLM augmented search of OpenAlex. So the principal idea is OpenAlex is a database of scientific literature. It supports keyword searches, and litdb has supported that as well. So we have like a command litdb OpenAlex, and then you can give it a query. And here we'll look at what happens. This is going to run that command in a shell, and it'll print like the top 5 results. Now, identification of goat sounds is an unusual query, I concede, but I recently saw a paper on this topic that cited one of mine, and I was interested in learning more about it. Now you can see that it doesn't do a particularly good job of finding papers that sound like identification of goat sounds. There are some things about goats, but then there's some things that are actually hard to understand why they're in here at all. So that brings me to the lsearch command. And what lsearch does is it'll take that query and generate a sequence of new keyword searches to do an OpenAlex. And then for each one of those keywords, it runs a query, and it runs it in 5 different ways. So we run the query and sort by publication year, ascending and descending, so we get the newest articles and the oldest articles. We also sort by citation count, so you get the highest cited and the least cited. And then we do a random sample of that keyword search, and that will generate something on the order of 150 results. Then for each one of those results, we get a vector similarity by sentence transformers and sort them, and then we return the top K matches. So let's do lsearch now on identification of goat sounds with the default settings, and it will generate some new keyword queries. It's going to show us what those are. So it takes identification of goat sounds and generates, automatic recognition, species identification of goats. These are LLM-derived keyword searches that are running. And then it does 5 of those by default. It gets 25 matches per query, and then it does 5 queries. So that's 125 or something like that per subquery up here. And you can see these are now much more related to the sounds of goats and classification and things that are related. So we might say, classification instead of identification. And this will give me, again, the top 5. These scores are a vector similarity distance, so smaller means more relevant. So again, we find, some interesting articles on using sounds from animals to learn things about them. Some of these are now adjacent, dairy cattle, etc. Okay, there are some options you can choose. Typically, you can control how many queries you get with -q. So if you only want 3 keyword queries, you put -q3. And then if you want 50 hits per query, you put N50. And if you want the top 10 here, then you say -K10. And let me change this to classification. And then we'll run this. And now this will only generate 3 queries. And the queries are not deterministic, so if you run this more than once, you'll get slightly different versions. Maybe we'll do that here in a moment. So you can see, like, qualitatively we got some and. Here we see more papers about goats. This paper in particular is the one that cited my vector search in molecular simulation paper, which I thought was pretty interesting. So if we run this again, we should get some slightly different queries. Now these are still all running on keyword searches, but the idea is that we can get lots of them and then use a similarity algorithm for determining which ones are most relevant. Okay, I'll take a few minutes here and just kind of walk through how the code works. It works like I described earlier. You give it a query. We have the number of keyword queries to generate. That's done down here. I have a LLM that has a system prompt that says you're a deep researcher that outputs valid JSON. It analyzes the query to identify Q full text queries based on keywords that could be relevant. And so it generates, in theory, some JSON. And then this is a little bit janky because I tried to make this very flexible with light LLM, but it turns out not all models are capable of guaranteeing JSON output. So I have a little bit of cleanup here, and even still, sometimes loading that JSON fails, so we catch it. Then for each one of those queries, I go through the cited by count in ascending, descending, publication date, ascending, descending, and we gather all of those results. And then I have a sample equals true option, and that gives us a long list of papers that are found. I deduplicate those as much as possible. And then for each one of those results, we get a text string that includes the title and the authors and the abstract. And then I use a sentence transformer embedding to encode those, and we get a cosine distance here. So we take the cosine similarity and then 1 minus that, and then I return the top k that are sorted. And that gets run inside the litdb command line interface in the way that I just showed you. Okay, so that's sort of the new feature, which is a hybrid keyword vector similarity search from OpenAlex that automates, trying to find the most relevant articles. Still a little bit stochastic. You could do all kinds of variations, but it seems like getting, a few hundred matches and then sorting on some similarity metric is a reasonable way to find relevant papers, and better than just taking the top K searches from a keyword search, which isn't related by similarity except through it contains some of those keywords. All right, you can find the new version on GitHub, and you should be able to pip install from GitHub directly for the bleeding edge version. That's it. Hope you